Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your redshifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So, Ro.
Hola!
Hola. Particularly, hola a Colombia.
Sí.
Muchas gracias a todas las personas de Colombia. Porque Through the Telescope es el podcast número uno on Colombia.
I was waiting to see if you knew the word for charts in Spanish. So for those of our listeners that don't speak probably
butchered
poor Spanish, we peaked at number one.
Mm-hmm.
Was it astronomy?
Number one in astronomy podcasts,
in Colombia.
Colombia on Apple Podcasts.
Exciting.
Very exciting. First Colombia, then the world. Also, I think last week or the week before we were number 8 maybe in Spain for astronomy podcasts.
Oh, wow.
But we were the top Anglophone podcast, astronomy podcast in Spain. So
that's cool.
Yeah.
Reaching all around.
Thank you to all of our Colombian listeners.
Yeah, particularly to our Colombian listeners. But thank you to all of our listeners anyway.
Yeah.
It's nice to see the podcast doing well.
Yeah. We hope you still keep listening despite horrific Spanish. Today, Ro, we are talking about the moon.
Yes, a nice chilled one, I think, this week.
Not just any moon, but our moon. Some people call it lunar. Do you call it lunar?
No,
Don't
I call it the moon.
The moon. So Terran of you. So geocentric.
Yeah, I think actually it is. Lots of other planets, asteroids, whatever, have moons. So why should ours be the moon? And the answer is that's just historically what it has been,
Yeah.
And we named all those moons because of the moon. But yeah, I do kind of get when I stop to think about it, I get a bit of an uncomfortable feeling, because it should have its own name, and it shouldn't necessarily be that all moons are called that because of us. Well, in some ways there's nothing wrong with it, but it is just part of our egocentric view of everything, isn't it?
Yeah. Our moon is the 5th largest moon in the solar system, which is pretty good going for a little planet like us.
I mean, that's true. Yeah, that's look at you. You've been scrubbing up.
I've been scrubbing up. On
your astronomy facts. I'm proud of you.
Yeah, it helps with the Kiddiewinkle again.
Yeah, that's an interesting perspective. I mean, it's true.
Punching above our weight.
But I was surprised to hear you say that, because I thought you were going to say, it's only the 5th biggest moon. I feel like that's quite a common response when people hear that.
Well, we're recording this episode this week where Saturn's just got another 62 moons.
Yeah.
In one fell swoop. So you know, I feel like...
None of them are going to be massive.
But getting into the top 5 when the larger planets have got, like, big chunky moons. Not that those 62 are, like you say, but, you know.
Yes, although I would expect that whilst bigger planets can probably more easily get bigger moons, I would also expect that the moons would suffer larger tidal forces. I mean, that's where the rings of Saturn and other planets are thought to have maybe come from, having once upon a time been moons.
The fragmentation.
Disintegrated, essentially. But yes, I mean, you would expect... It seems logical that a bigger planet would have bigger moons, so
yeah. I mean, sometimes in space logic it isn't quite right, because there's another form of... There's other stuff going on that you don't appreciate into your logic, if you know what I mean.
Yes.
So, it is 1,080 miles in radius, or 1,740 kilometres, for those not in the imperial world.
Yeah, see, at this point, we're reaching the limits of what miles means to me.
Right, yes.
You know, like... going for a walk, going for a run. I've been trying to train myself to use kilometres, but miles kind of comes more naturally to me. It's what we're brought up in the UK.
Same.
But once we get to these kind of numbers, that does not mean anything to me. Everything's kilometres at this point.
To put it into perspective, the radius of the moon is pretty much the same as if you walked 500 miles and then you walked 500 more. In the Proclaimers song, which is about a third of the radius of the Earth.
I'd never thought of the Proclaimers in terms of that before.
No? Yeah, it's quite a long way to walk.
Yes.
It goes to show their devotion.
Yes.
You see.
That is quite a long way to walk.
Yeah, the radius of the moon. Yeah. And then you put it into even larger numbers, it's then 239,000 miles, or 385,000 kilometres from the Earth, on average, to the moon.
Yeah, on average.
On average, that's its orbital radius.
It does have a bit of an ellipse going on.
So, those are some numbers.
Well, back to some smaller numbers then.
Okay.
Do you know how hot the moon can get?
Well,
when it's in full sunshine.
It doesn't have an atmosphere, and people have been there, and it's in the vacuum of space. So I would guess that it would be maybe about freezing or a bit colder. So 0 degrees C, something degrees Fahrenheit. Is it that?
No.
Okay.
Far from that. In full sunshine, the temperatures get to about 127 degrees Celsius, which I can tell you in Fahrenheit, it's 260 degrees Fahrenheit.
So
quite hot.
So how do people go to the moon and not melt?
Spacesuits.
Spacesuits. I guess because there's no atmosphere, that's fine. That's just the temperature of the rock. Yeah. Okay, so that's when it's in full sun.
Yes.
Right.
In darkness, temperatures are very cold. About minus 173 degrees C. Or minus 280 Fahrenheit.
Okay.
So it's a pretty large range.
Well, that's quite nice in Fahrenheit, because that then goes from 260 degrees to minus 280. So it's almost like a perfect flip. Not so much in Celsius, but that's a big range.
Yeah.
That's like 300 degrees C, like 500 degrees Fahrenheit difference.
Yeah, very little temperature regulation really going on there.
Yeesh. Okay. Well, I wasn't expecting that. That's like a bit like Mercury in a way, isn't it? With massive temperature changes between night and day. More so than this, but...
Yeah, I suppose Mercury and the moon have quite a lot in common in many ways.
Being a barren, atmosphereless rock.
Yes.
Is the moon then just rock? Like, is it all the same all the way down? Or does it have, like, a core like the Earth? Or is it just rock? Is it too small to have anything like that?
Yes and no.
Right. It's always good when that's the answer.
I mean, it is rock. It does have an interior.
Okay.
Similar to the Earth, analogous to the Earth, of a core, a mantle, a crust, which are probably things that everyone is used to hearing from geography or geology in high school or whatever.
Yeah, and I think we talked about it before, when you cut into the bit and they pull a little section of the Earth out and you can see the sort of gumball-like structure or whatever.
Yes.
Yeah.
So the moon has a similar thing going on. But it's also quite different in some ways.
Okay.
The core is only partially molten.
Right.
It used to be very different to how it is now. It would have had a magnetosphere, so an actual magnetic field around it.
Okay.
Generated in the core of the moon.
So as the core has presumably cooled, then
things
it's
aren't
lost
really moving anymore, so it's not really making a
magnetism.
magnetic field, so it doesn't have anything to protect it from the sun, which is what the magnetosphere of planets and moons, mostly do. Also, it would have had volcanoes as well.
Right. Okay. So
if it's got, would have had that similar kind of rocky planet-esque.
If it's got a core and a mantle, then you can maybe imagine volcanic activity going on, kind of thing.
But it's not had much going on. It's not been very active for millions of years. Because the moon is, it's I don't want to say it's small, but relatively speaking, it's quite small. It's too small to really be able to sustain that, because you need to have a big enough gravitational force to keep your core liquid.
Right. Yes. Yeah.
The gravitational force that you have as a planet or a moon is what creates a lot of pressure inside of your body, and therefore you have your core and
high temperatures
everything.
And
that comes along with that, like your magnetic field and all of the activity. And the moon, whilst pretty big for a moon, is not really big enough for that kind of thing. The moon is kind of similar in size to Mercury, as we kind of hinted at earlier.
Yes. Now Mercury,
and Mercury isn't able to sustain that either.
So, given that it is, not a planet, but it is quite big for a moon, why is it that Earth, as one of the smaller planets, not the smallest, what are we with the third or fourth smallest? We're similar to Venus, right? So
yeah, we're bigger than Venus.
Okay, so we're like the fourth smallest, largest of the terrestrial planets.
Yeah.
Pretty good for what we are.
You threw me because you're talking about like the fourth smallest, and I just think of it as
the
biggest.
fifth largest.
Yeah.
So given that we're big in our solar system for a
rocky planet.
Mm-hmm. Is that why we have quite a large moon, or not? Like, why is it that we have a large moon, whereas, say, Mars, which I guess is the next most similar case, it's got two little moons, right?
It does, Phobos and Deimos.
So why have we got one big one?
You're asking the big questions. As with many things in astronomy, we don't really know the answer.
Okay.
It might help us to look at where the moon came from in order to answer that question.
Right, yeah.
So moons can form in lots of different ways.
Mm-hmm.
And one example of that would be they might form in place. So as the planet is forming and it's going around the star, you think of your solar system at the beginning, and you've got the sun, and you've got just like a disk around the sun of dust and gas and other stuff that hasn't been sucked in or accreted onto the star. And all of that disk is what is going to become everything else in your solar system.
Yeah.
So your planets, your moons, your asteroids, your comets, everything is coming from that disk. As a planet is forming in this disk, you could have a moon also forming in place.
Okay.
At the same time.
Sort of like a second planet, but very small, that's nearby to...
Yeah.
The sort of two clumps, one gets larger and the other one doesn't get sucked in to join with the planet forming. It instead forms independently, and they reach a happy equilibrium where they...
And one of them is probably going to be getting less material than the other one. You get some sort of imbalance in the size of them. They could form instead in a kind of fission method.
Okay.
Where a planet spins really, 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 really fast.
Okay.
And some material kind of, gets thrown off and forms into a moon.
Right, okay.
It gets thrown off, but it doesn't escape.
Yeah. Yeah. It gets thrown outwards, but there's still a force of gravity between the planet and that moon that pulls it into its orbit.
And it creates a kind of stable orbit in which something like that has happened. There are other ideas of how you could get moons as well, but that's like two examples.
Are these things that we are aware of happening, or I feel like this is like a stupid question? Are these things that we... I guess we've not observed this happening, right? We've just worked out that these are possibilities.
As far as I'm aware, they come from simulations.
Right, okay.
So, there are kind of two obvious branches of astronomy, or two ways that you could obviously categorize different types of astronomy.
Yeah.
One of which being, take your telescope, look at things, collect lots of data, analyze the data. What does the data tell you? A kind of observational astronomy, if you like.
Yeah.
And then another side would be creating models and simulations of what might happen for things in the universe.
Right.
So that might be how a star is formed, or how galaxies are formed, or how galaxies, interact with each other and disturb each other, or combine into one galaxy, or how moons are formed, or how solar systems are formed.
Yeah. And we're not able to look through a telescope and see, oh, there's a planet spinning really fast. Well, a moon just came out.
Yes, exactly.
But we could maybe, I don't know, look at how the mass of the planet and the moon, how they're spinning, and then work backwards with sort of a theoretical sort of pathway, as it were, and be like, okay, well, if we added it together, then this would be this mass, and it would be spinning this fast, and if we put that into a simulation, that's spinning too fast, and then it's like you're at a potter's wheel, and your vase all of a sudden throws a like massive glob of clay out.
Your handle falls off.
Yeah. Do they use potter's wheels for that simulation, or do they just do it on a computer?
Mostly on computers.
Mostly.
the odd potter's wheel, maybe. So there are different ways that you could make simulations. You could make one that is exclusively, mathematical or equation based.
Mm.
Or you could have ones where, like you say, you input some sort of observational data
Right, yeah.
A lot of them in reality are going to have both aspects going on in some way.
Yeah. And I guess it also depends if you want to talk about, like, moon formation versus this specific moon,
Yeah.
as it were.
Yeah, exactly.
Yeah. Okay. And so which one do we think the moon came from?
Neither.
Okay. So have we talked about those two? Okay, what's the third method of moon
Because
making?
I thought you might be interested.
I was, yeah. Third time's a charm.
Our moon seems like it doesn't quite fit either of these things.
Right.
There are various factions
Okay.
that have that side with various different things
Okay.
on how the moon might have formed or whatever. But
And astronomers really...
we faction hard.
Yeah. It's like you put 3 astronomers in a room and you come out with 4 different explanations or something like that.
It can feel like that sometimes. The composition of the moon doesn't seem to be the same as the Earth's.
Right.
Not like identical.
Okay.
It probably therefore didn't form in parallel with the Earth.
Right, so that's the...
It probably didn't come from the same, strip of disc.
Right.
Otherwise we would, expect it would be made of exactly the same stuff.
Okay. So does that mean we've captured it as something, as it being thrown out from another planet, and we've grabbed it?
We've grabbed it. Our gravitational potential has been enough to make it into our moon. No, but that is a way that moons can form. We wouldn't really expect it to have a circular orbit if that was the case. I mean,
Okay.
I use that term loosely. It's not like it's an exact circle.
We'd expect it to be
But
more of a ellipse or something.
It's pretty, it's pretty circular in the loose sense. So it's probably not being captured because, like you say, you would expect something much more elliptical, kind of more, I don't know, extreme. Do you know what I mean? If you captured it, it would just be unlikely that it would happen to
It wouldn't be going around in
circular.
a nice circle with the Earth at the centre. It would be more of an oval shape with the Earth at one end of the oval or something like that.
Yeah, that was very eloquent compared to my attempt. Thank you.
Let the listeners...
I'm glad you
decide
understood what I was trying to say. Earth doesn't spin that fast.
Okay.
And it couldn't have slowed down that much in its life. So it probably isn't the fission case either of throwing something off your potter's wheel. Also, the moon doesn't orbit at the equator of the planet, which would be more likely for this method. You find yourself in a play park and you are very unfortunate to find yourself on a roundabout.
Okay.
If you have something on a string that's, not stupidly heavy, but or a sock full of porridge, if you like. Maybe
We've brought a real random selection of things to the playground today.
I can't take responsibility for the sock full of porridge. That's a professor within my department who uses that one a lot, so I'm going to borrow it for this toy experiment. Right. And you spin round. Your
porridge
roundabout starts to spin.
Okay.
Kind of naturally, your sock of porridge is going to end up at right angles to the ground. Yeah,
it's going to get thrown out the way-ish.
Yeah.
Especially if you start to go really fast.
It wants to be perpendicular to the axis of rotation. Yeah. So it's your roundabout is rotating, hopefully, around you standing up.
Yes. Okay, so you're at the middle of the roundabout.
Yeah, you can be if you want.
Okay.
And so, your head is always pointing upwards, I feel like.
Yeah.
And the porridge always wants to be with your arms, wide out.
Mm-hmm.
Kind of parallel to the ground. It naturally wants to do that. It wants to be... The moon would be the same. It would want to be in the equator of the rotating Earth.
Yeah. And then if you went to a really weird kids' playground and you tilted the roundabout so that now it was not flat compared to the Earth,
yeah,
and you did the same thing, it would still want to go out from the roundabout.
Yeah.
Especially if you went fast enough.
Yes. And you would feel really sick afterwards.
Yeah, it wouldn't stay parallel to the ground, as it were. So if you're saying that if the Earth spanned really quickly, or the pre-Earth spanned really quickly and shot out the moon, it would keep on going around the Earth's equator, even though that is not lined up with the Earth-Sun orbit, as it were.
In most cases, yes. That is more probable.
Okay.
And the moon isn't following that kind of orbit, so...
Right. So we've not made it out of the same clump of dust and rock. We've not spat it out from spinning too quickly for multiple reasons, and...
We've not captured it.
We've not grabbed it.
No.
So that means aliens? I don't know at this point.
Well, a common consensus is that it was formed in some sort of collisional event.
Oh, right, yeah.
So, it would have to be a relatively large object to do that. It's not going to be a tiny, comet or something.
Right.
And if you had something that was about the same size as Mars, this could work. Therefore, it's probably a planet.
Right.
Because Mars is,
It's a planet.
Is a planet. It's a pretty big object, really. I mean, I know it's not huge in the solar system, but it's not. It's definitely a planet. So, probably the Earth at some point in its history collided with another planet, similar in size to Mars, and this planet often gets called Theia. And this collision basically ripped out a whole chunk of the Earth and also presumably Theia, which then formed into the moon. So that the moon would contain some Earth material, but also some other material.
So Theia is the daughter of Gaia and Uranus. She's a Titan. More importantly, though, she is together with Hyperion.
Interesting.
One of the parents of Selene, the moon, but also of the sun and dawn. So let's not get too carried away with
Interesting.
So that's it. So she's the daughter of Earth and the mother of the moon. So it kind of fits.
It kind of works.
But
it does kind of work.
Kind of. Definitely with the moon bit.
So that could explain basically why it is so much larger than other moons relative to the size of the planet.
Because it's actually a remnant of a planet.
Yes. But not everyone agrees that this is the method at which the moon formed. We don't really know. And I do think there are still questions, like why, if we think that the moon has a different composition to Earth, then why, if they're both made from Earth and this planet, are their compositions significantly different? You know, I think that... I'm not saying that can't be explained in this case, but that can't be glossed over. You know what I mean? So, yeah, it's a very interesting question.
But that's also there's so sorry. It's just I just find it kind of is that likely? You know when you're saying like the sort of the go-to moon formation things are it formed along with it, or it got spat out. Maybe it got grabbed hold of it, especially for smaller moons, I guess.
Mm-hmm.
But is it common that two planets smash together? Is it dependent on different bits?
Well, I couldn't tell you off the top of my head how common that would be. I'm not sure, even with time, I could tell you that. I mean, I don't know how much literature you would have to search through to get any sort of answer to that. Perhaps I'm just naive, but that seems like a difficult...
You're presumably not going to have 1% of moons as a figure.
Mm-hmm.
You know? And even if it was, then it would be caveated with, of the moons that we've seen and we think we can explain.
I mean, what I would say is the universe is huge, and one thing I've learnt from other fields is that there are a lot of cases in astronomy when you look at, you know, galaxies or solar systems or whatever, where you can't necessarily explain something by one mechanism. And it's, you know, relatively common that multiple mechanisms are responsible for things. For the same, you know, the same thing, like making a moon.
Yeah.
And you can have things that seem, you know, relatively uncommon. Maybe it's 1% of all moons, but when you look at how big the universe is, that's gonna be a lot of moons.
Yeah.
Obviously, that doesn't necessarily mean for the one particular one that you're looking at, the chance is that high. But, yes.
I guess also when you've got clumps of smaller rocks coming together at the beginning before the planet is even formed, that's rocks smashing together. So in the grand scheme of things, it's just like two really big rocks smashing together.
Well, during formation of the solar system, they're all a lot, you know, there's more material closer together. There's a lot of gravitational things going on. A lot of kind of pushing and shoving, if you like. It does, however, lead quite nicely into the thing I was going to say next.
Oh, right.
That at certain points in the history of solar systems and our solar system, we think there could be a reasonable amount of kind of argy-bargy of planets.
Right, okay.
You know?
So is this kind of like...
And planets do migrate. We know that planets migrate around stars, and by migrate I mean they change their orbits.
You don't mean move. Like they winter in one place and they summer in another place?
So they can be further out and then move in to the star, or move out from the star.
Okay.
And, you know, it's not unfeasible that perhaps that is directly responsible for an event like this, or maybe indirectly responsible.
Right.
If Jupiter moved from further out and got closer, then all of a sudden...
There's another planet that's now had it was fine before, it wasn't really being influenced by Jupiter massively, but now Jupiter just got closer, so now it's been
yeeted, and it's, you know, eventually been unlucky enough that has then...
headed straight towards, in a sort of snooker pool kind of way.
Yeah, and it doesn't necessarily have to be a kind of Hollywood-style movie of Jupiter moves, for example, in this scenario. and then the planet just gets yeeted directly into Earth.
Yeah.
You know, it could be that then over millions of years...
It's altered its orbit. It's trying to work out where its new orbit is, stabilise itself, but in the process it's being shot round in sort of...
Yeah.
What's the word? Erratic kind of orbits, until eventually somewhere on that erratic path the Earth happens.
Yeah, and then the moon happens.
And then the moon happens. And that's where moons come from. Okay. So I guess that's kind of like a fusion, almost. If there's a fission method of moon formation, this is kind of the fusion method.
Yeah, I suppose it is, yeah.
Although maybe that's the accretion bit.
Yeah, perhaps that is a term that they use for something else. I don't know.
I know as a kid and even as an adult, there's something about me that, even though we only see one side of the moon, or because we only see one side of the moon, and there is a light side and a dark side of the moon, maybe it's just the name dark side, even though I know that the bit of the moon that is light changes over time, I feel like the other side of the moon is in constant darkness.
Right.
Do you know what I mean?
Yes.
That was a long way of saying that, but...
Yes.
The dark side of the moon feels like it should always be dark.
Yes. Partly because of the name it's been given, and partly because your entire perspective is from Earth.
Mm-hmm.
If it makes you feel any better, I've felt similar ways before when I've tried to make cartoons of, you know, how the phases of the moon work.
Yes.
And I've got, like, the sun there, and I've got the Earth, and then the moon goes round, and then you colour in the half that gets sunlight because it's facing towards the sun, and then you work out which bit of the moon you can see from the Earth.
Yes.
And, yeah, it just, like, twists my brain. I'm like, wait, but where's the dark side of the moon?
Yes.
It's the bit that's not facing the Earth. Even though, you, like you say, you know it, you know that fact.
Mm-hmm.
But, yeah. It's a very romantic name, but it's not necessarily that helpful.
Yeah.
It's not always in the dark.
When I was looking up things about the moon in advance of this episode, I saw that the first time that we'd ever seen the other side of the moon, the far side of the moon, was in 1959 with Luna 3, a Soviet probe. But it was also weird because it then had a picture of the dark side of the moon in light, because it's not the dark side, it's just the far side.
Yes.
You know? And I was like, what's that? Yeah.
Yeah. I find any picture of the far side, you're right, we should call it that. We should remove dark side from...
It sounds more Star Warsy as well.
I don't know what the word is, not lexicon, but...
Yeah?
Whenever I see the pictures, I'm always like, what is this?
Whose moon is this?
What is this object?
Yeah.
Like, we're so used to seeing the moon as it is because we only see one side of it. That is our picture of the moon. And we see it throughout our lives. You know, hopefully a lot of people are lucky enough to see the moon quite a lot.
Yeah.
We really do know what it looks like. Even if you can't draw it, your brain really does know. As soon as you see it from a slightly different perspective,
yes,
even if it's a picture of the surface of the moon where a bit of what you know is there and a bit of it is not the bit that you see.
Yes.
My brain just does not... What is this?
Yeah.
It's so alien. It's our closest neighbour, but...
Yeah. But the far side of the moon, going back to that, is featureless but more rugged and just being sort of bombarded, it seems. It's
Yeah, well, the bit that's facing us is not likely to have many collisions on it.
Because it's more protected. Also, the CNSA, the Chinese Space Agency, their Chang'e 4 was the first probe to land on the dark side of the moon, the far side of the moon, in 2019.
Mm-hmm.
I say land, it was the first soft landing, which I think means didn't crash.
Yes.
Which is important. I think we had stuff fall into it before. If you ever wonder who it is that names those craters, it is the answer to all of these things is the IAU, the International Astronomical Union. So they're the people that are responsible, although other things have existed in the past and are still sometimes used. So there's like certain sites that NASA have named during the moon.
Yeah, well,
program.
as with all these things, eventually, well, not all these things, but as with things that have been going on longer than the IAU had any power for,
Yes.
things that have already been named already have a name and typically a convention, and they will often stick.
Yes. Yeah. But some of them aren't recognised by the IAU, so I just feel like it's important to point out that other naming things do exist. But that being said, if you want to have a crater named after you, you need to be a scientist or explorer who has made a significant contribution, preferably to the study of the moon and or the planets. So if you tick that box, you're okay. Second of all, you need to be deceased for at least 3 years before you get your crater named after you. If that also applies to you, I'm not sure how you're listening to this podcast. And number 3, it can't be a duplicate of an existing lunar name. You can't have 2 craters with the same name.
Right, but not every crater is named after an astronomer or scientist.
Yes, so again, this is,
for example,
the current IAU guidelines.
This must be quite new.
Previous things that other things got passed, so yes.
This must be relatively new, because did you know there is a crater named Michael Jackson?
Michael Jackson invented the moonwalk. Not even...
If that was their link, then that is very tenuous.
Do you know what? I only just thought
that. That's fine. But, like, not a scientist or astronomer, is he? So.
Well, yeah.
Yeah.
Yeah. Jules Verne, also not an astronomer or explorer in the traditional sense, so...
No. Though there are craters named after Buzz Aldrin.
Not Buzz Lightyear.
Neil Armstrong and Yuri Gagarin, amongst other people.
Okay.
So that's, they feel obviously in keeping with that requirement.
So we're doing very well for white dudes.
Yeah, when I looked through the list, it was very heavy on the white dudes that the craters were named after. Did find a few exceptions to that. A couple of examples being Hypatia, Wilhelmina Fleming, which we talked about in the stellar classifications episode.
Yes.
So you should check that out if you haven't already.
I'd say she was the most important person in that episode, apart from Annie Jump Cannon, who, so, I just feel like she
also
should...
Also pretty important.
Yeah.
Zhang Heng. I apologise if I have butchered that. But yeah, a lot of the others.
So it's not exclusively, but it is.
But pretty much exclusively.
Probably. I did also
I was struggling to find people that weren't European white men.
Fair. Yeah. To be more specific when it comes to craters, as well as all of those caveats, Russian cosmonauts tend to be commemorated by craters around the Mare Moscoviense. That's probably not how you say that. Whereas American astronauts are commemorated by craters about the Apollo crater.
Mm-hmm.
So, yeah. And the IAU says if anyone else gets to the moon, we'll work it out at a later date and we'll pick somewhere for you. I don't know how they do that when they've already named how many of the craters, but yeah. And I do just love that people sit on a committee and have to work out these things, because there's also, like, if you want to name a dorser on the moon, which I had to look up what it means, and a dorser is apparently a hill on a moon.
Yeah.
You have to be a geoscientist, apparently, under the newish rules. So they've got a weird array of things.
Feels very much like a committee, doesn't it?
Yes, and things like apparent oceans or whatever should be Latin terms describing the weather and other abstract concepts. So
Okay.
when you think of the Sea of Tranquility, that's a weather term. So it's a nice tranquil sea. I feel like people name things and then they've got to work back.
I think they've got too much time on their hands, personally.
You've got to love a committee. But how many people have actually been on the moon so far?
12 have stepped foot on the moon.
Okay.
4 of which are still alive.
Nice.
Which is pretty good going.
That's pretty good going.
Yeah. Buzz still going from Apollo 11. David Scott from Apollo 15.
Okay.
Still alive. Charles Duke, or Duke maybe, I guess. He's American, so.
Yeah, I don't know.
Apollo 16. And Harrison Schmitt from Apollo 17.
Is 17 the last one?
Yes.
Okay.
So 12 that have stepped foot on the moon, but 24 have been into lunar orbit, which still counts as going to the moon.
Right.
So
That is a bit
weird. Kind of depends
weird
what you're asking.
that only half of the people that went to the moon then set foot on the moon.
Yeah, well, you always have to have someone
Hanging about on the thing.
doing the actual keeping everything under control. So, 24 have been to the moon between the years of 1968 and 72.
Okay, so they've gone round at least.
Yes.
So is there anyone that has been to the moon twice?
Yes.
Or
3
more.
people
Okay.
have been twice. James Lovell, Apollo 8 and Apollo 13.
The name Lovell seems to crop up quite a lot in space. Just an observation.
Okay, I don't know what to say to that, but... Right. John Young, Apollo 10 and Apollo 16. And Jean... Now, I apologise. I don't know if it's Cernan or Kernan.
Okay.
But Jean from Apollo 10 and 17 has also been twice.
So, John and Jean were both on Apollo 10. It's the one just before the first moon landings.
Yes.
And they were then on
Later
the last
missions.
and the second last one. So that's nice that they then got to, go again.
They've kind of seen it all as well, haven't they?
And I guess the same with James
Into
Lovell. Apollo 8 is that one of the first ones that actually orbits the moon in the first place.
Yeah, must be.
It's early. Okay. So we've
6 other crew survive, as well as the 4
okay, so we've
left that have walked.
got 4 moonwalkers and 6 people that have been around the moon but not walked on it. Okay.
Yep. So
And
10 people alive today that have been to the moon.
And all of the Apollo missions from 11 onwards included a moonwalk, because otherwise, what the point? With the exception of Apollo 13, which had Kevin Bacon on it, and something went wrong.
Yes.
And we're going back.
We are going back. Yes. Artemis 2 will return in Flyby with Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. We're having the first Canadian,
Wow.
first woman, and the first person of colour. It's only taken a very long time.
Yeah.
But
About 60 years.
yeah, so there'll be another trip to the moon, and then eventually more moonwalks.
So there will be somebody who is the first non-American to walk on the moon in the Artemis missions.
Yes, if by American we use...
Sorry,
in...
from the United States of America.
Yes.
But this one isn't going to land on the moon. So Jeremy Hansen, the Canadian astronaut, I guess, is not necessarily the first
No.
non-American to
not...
United States citizen to walk on the moon, but is the first non-NASA astronaut to orbit the moon.
Yes, they're not necessarily going to moonwalk. They're not going to walk on the moon or land on the moon in the first mission in Artemis 2.
Mm.
They may be the astronauts that walk on the moon in the next mission, though.
That seems like a really difficult... Because the point of the Artemis mission, for one thing, is other nations, other space agencies that align with NASA to get involved with moon stuff, right? There's like the CSA, the Canadian one.
Well, the idea of Artemis 2 is to set up a moon base and commercialise
Nice.
it. And export or outsource certain things to other companies.
Right, yeah.
It should be collaborative. There should be other space agencies involved, but a large part of it is to commercialise it outside of the kind of space exploration
The national
sector. I'm not sure what the word is I'm looking for, but yeah, the National Space Agency, and into, involving companies. So having a company that generates the electricity that NASA buys the electricity from, so that they are not responsible for that.
In addition to those 24 people that have been to the moon in some shape or form, we've also sent 100 robots.
Yeah. Over 100, yeah.
And needless to say, the moon is the only place that humans have set foot on that isn't the Earth.
Yeah.
So, what's the point? Why do we bother going? Or is it just like a goal to go there because the Americans wanted to beat the Russians and vice versa?
Yeah, I mean, I think we've touched on that before, have we not?
Maybe, yeah.
The space race was not really about scientific exploration. Shall I read you what Artemis 2, what NASA and Artemis 2 say the point of going to the moon is?
Go for it.
We're going back to the moon for scientific discovery,
Okay.
economic benefits,
Right.
and inspiration for a new generation.
Okay. There's economic benefits like job creation in the space sector, or are we mining the moon for helium-3?
No.
No.
No. When we have talked before about how we gain things from space exploration, there are economic benefits and technological benefits of doing things like this that are hard. It drives a lot of technological advance, which also then leads into economic benefits as well.
Yeah. Yeah.
Yeah.
All of that jazz.
I mean, we do these things for lots of different reasons, don't we?
Yeah.
Everyone that is invested in going to the moon this time or going to the moon last time would have brought their own thing to that, and potentially more than one thing. We all have put different values on different things relating to huge scientific, exploration and things such as this.
So you say that Artemis wants to have a moon base at some point? Yes. In fact, I think I've seen a picture of, is it Toyota that have got a prototype for a new lunar rover?
For the rover.
The moon buggy.
Yeah.
But
it's not a buggy.
It's not a moon buggy. It's
like
not janky. It's like a proper.
It's like a people carrier.
Yeah, you'll probably be able to buy it. Not quite, because it'll be like millions of dollars, but it looks like a car on the moon.
Futuristic.
Yeah.
Looks like something that they would have drawn in the 60s and said this is the future.
Yeah.
And that it is, apparently.
So when are we hoping to get onto the moon before, I guess at a later date, we'll start driving onto the moon, but when are we thinking of having this moon base?
NASA's Artemis mission hopes and plans to land by 2025.
Okay.
Which has been pushed back, I believe, a little bit. And then have a sustained presence on the moon by 2028.
Because you've got to do lots of missions to take the stuff to set the place up in the first place, right?
Yes.
I think
to have a sustained presence is very different to visiting for a moonwalk or whatever. So it will take time between first landing and being able to stay there for, have people have it crewed for most of the time, if not all of the time.
And a sustained presence is presumably also not like the end. Like, this isn't like the moon base is finished now, because I think the ISS took like 10 years or something. They built a bit, they were up there, and then they kept on adding bits and pieces to it.
Oh, yeah. It's not that by 2028 they hope for it to be completely finished, job done.
But they hope to have people staying there
will,
for quite a large amount of time.
Yeah, their hope is that by then, astronauts, cosmonauts, any, what's the Chinese?
Taikonauts?
Taikonauts,
I think the French is aspasionaut as well. But I don't know how often they use that.
For them to be able to stay there and survive, basically. They're not living the high life. They're having a great time in some ways, I guess, because they're on the moon. But there'll be a lot of work to do to make it into what they hope it will finally be,
Yeah. That's kind of weird. You'd be like the first people to live on the moon for like a period of time.
Yes. Yeah. But, and I don't mean to put it down or anything, but realistically NASA have had a lot of plans before to have a moon base. And evidently that has not happened.
Right, yeah. That we know of.
So, and things do and can get delayed, and quite rightly should be delayed if they're not going to, be able to do a great job and 100%, be comfortable in how safe things are or aren't, it's not things that you should be rushing. You should only do it when you're, you are ready. So we'll see how those numbers work out.
Okay.
And they're not the only ones
Right.
to plan a moon base. China and Russia together announced in March of 2021
Right.
that they were going to team up on an ambitious project called the International Lunar Research Station.
Right.
ILRS. And basically, the aim is to make a base on the moon near the South Pole.
Where is Artemis putting theirs down? Is that the same kind of place?
Yes.
Okay. I mean, neighbours. Right, okay.
But we don't really know exactly how that's going and how on board they both are with this project now.
Yes.
So who knows about that one? It was a project that they said had kind of 3 phases to it. The first being the kind of preparing stage. The second being like a building phase. And then the third being
operational stage. Well.
And currently they're kind of in the planning stage in the sense that not like sat at the table with their blueprints necessarily, but collecting data on all sorts of different things to give them insight and ideas and inform them on how to go about making a base. So they have, lots of robots that are already... They can use data from things that's already been collected, but also they have access to the probe you talked about earlier.
Chang'e,
yeah.
4.
Which is still in operation.
Yes.
And they're using that, amongst other things, to collect the data that they need to allow them to progress with the project, if that happens. And the plan was to start building by 2026, and that it would take about 10 years.
Okay.
So, in theory, not that far away either.
Yeah. And China also has, I think, has it sent up the last bit? Or it's about to send up the last bit of its space station, and it's the only national space station in orbit, and if the International Space Station is to last as long as it's meant to last, which is not that much longer, then China will have the only space station in orbit of the Earth. So it's not just NASA's doodah or Roscosmos anymore.
No, it's far from it.
And ISRO, is that the...
Yeah, the big Indian.
India's got a couple.
One. Yeah. Yeah, it's a different landscape from what it used to be.
Yeah. More competitive between different nations, different space agencies, and now different companies. So
it's a new phase of space exploration. And, probably most of us listening to this, speaking on this podcast, will see a lot of that in our lifetime. Yeah. So, yes.
Yeah.
It's going to be an interesting ride.
Yeah. Well, I mean, the moon is very important to us in terms of life, having tides, and other things that we are aware of. But it does hold a particular place for us, sort of culturally, spiritually, and historically, and now into the future too. So I guess we'll see what comes of it all, and we'll definitely be very excited for any future moon landings.
Yes, it's kind of interesting, you know, our parents' generations remember the moon landings. My mum's probably going, I'm not quite that old to remember it. But, you know, and I just think that must be fascinating. And then, you know, our kids' generation are going to be the same. If there is sustained presence on the moon by 2030...
That's pretty crazy.
Then it will be a completely normal part of life.
Yeah. We'll actually be living in sci-fi at that point, which I guess is the same thing. That's what you're saying, right? It's like the same, like, people could never walk on the moon when they did. And so people could never live on the moon, and people live on the moon. It'd just be like the ISS now, which is not that weird, is it?
It's completely normal. You know, most kids that you that you meet in life like space, right?
Yeah.
And it's so normal to a lot of them, yeah. Like, there's a satellite up there that people live on.
Yeah.
You know, and it's like...
And
when you think about that, that's wild.
You know, with the original moon landings, it's like, oh, this is one small step for man and all that jazz. And like that's the video that gets sent back to the Earth, right? The transmission. Yeah. And, you know, they had multiple transmissions. But nowadays we have the, hi, school kids, I'm Jeff from NASA, and I'm floating and showing you how I can drink water in little bubbles floating about, kind of thing. Or when, in the UK, when Tim Peake went to the ISS, it was very much like, got to get Tim Peake to go around all the primary schools and talk to everybody, and then he's got to like be on telly on the ISS and things. In like a decade's time, it's going to be like, hi, I'm Jemima, I'm on the moon. If I drop stuff, it still falls, but it's a bit slow, and that kind of thing. It'll be like, that's when you start to get the real normalization, because it's like,
yeah, it's just, you know, I mean, in theory, it's not going to be really that different to phoning someone in Australia.
Yeah.
You know, like my grandma has a friend, or had, I'm not sure, a friend who moved to Australia, and they went from having to write letters to each other, and, you know, how long does it take for a letter to get from Australia to the UK and then back? You know, like, that is not a short amount of time. To being able to FaceTime each other.
Yeah.
You know, or a phone call even. Instant access. I mean, obviously you've got the whole sleep schedule situation in that one, but it'll be the same, right? It's going to be the same thing.
Yeah, but
hi, I'm Jemima calling into whatever primary school.
Yeah.
What's it like living on the moon? Oh, it's great.
How do you poo on the moon?
Yeah, they will ask that. Kids will always ask that. Oh man.
Yeah. Easier than on the ISS. Yeah. I guess on the moon, a lunar day is a month. So that, although I guess maybe it's different at the poles. So I don't know what the time the time difference is there.
I mean, you also have issues that you have to make sure that you are putting your base in a place that
is in space.
You don't want the temperature to be as wildly, you know,
as we discussed, routine.
Going from really, really hot to really, really cold all the time.
You'd rather have it at one thing, whether it's really hot or really cold, because then your materials are not getting stressed beyond belief.
Yeah. And lots of other things as well. So you might avoid the night-day problem. You might have no day at all. You might be in a crater where it's cold, but you can deal with that because it's not also going to be 170 degrees later on. So you might not experience that at all. And there'll be interesting psychological effects as well of that, because we are seemingly very programmed, if you like, for the 24-hour clock. Our body clock really likes that. It seems that if you are on the ISS, you don't really have an issue because the ISS goes around so fast. I mean, you have multiple days and nights in a day.
Yeah.
And it's like so removed from the 24-hour clock that your body naturally wants to do that your body, it seems, just kind of gives up.
Yeah.
It doesn't try to fight it. Whereas if you had like a 23-hour day, if you started trying to live to a 23-hour day, your body clock would not cope very well with that because it would be kind of fighting it, you know. And it was previously thought that like any variation your body would not cope well with, but it seems perfectly clear from the ISS that's not the case because they seem to cope perfectly fine.
Yeah. I did see that I think
it'll be a different thing again once we get to the moon, and how will people adapt to that? And we don't know the answer yet.
What a sustained presence means as well, because is it one person staying there for 6 months, or is it like 6 years, or 6 days at a time for one person? You know what I mean? Presumably a fair amount of time. I think the longest on the ISS that anybody's clocked up is a Russian guy with like over 1,000 days total, which is over multiple missions, I'm pretty sure. So, like 3 years of their life.
That was a long time.
Yeah.
Wow.
Yeah.
I had no idea. That is a long time.
Yeah. So, I don't know.
Yeah, I mean, presumably their plan is for long enough, because you don't want to just be sending rockets all the time. You don't want to be doing, or at least not with the current rockets we have. Right, there's your 6 days up.
Yeah. We've got once a week like shuttle between the Earth and the Moon.
But you don't necessarily want to leave them for a whole year either. Yeah. So, I mean, I'm sure they have plans, and they probably have published somewhere what these plans are for their sustained presence. But it's not unreasonable as well to expect that things may change as we learn, as we go through this development process and learn about the situation and have to adapt things and the consequences of adapting that one thing. What else does that mean we have to adapt? And
I guess time on the ISS will have helped with some things like keeping up bone density and like exercise, muscle mass, whatever, as best you can on the moon with reduced gravity. But like you say, there's new challenges of people aren't keen on being on a dark hole or maybe slightly off a 24-hour day. So, yeah.
Yes.
See what we find out. I'm not going to the moon anytime soon, so I don't need to be the guinea pig. Well, with that, good night.
Good night. Good day.
Buenas noches.
Yeah, we'll speak to you next week.
So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and if you like, you can leave us a nice positive review as well. It really helps the show and it makes it easier for more people to find us.
Feel free to send us any comments, questions or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.